Math 3, Unit 5, Section 2. Today we are talking about standard deviation. Okay, standard deviation is the average difference from the mean. Do you guys remember what the mean is? The average of like a set of data, and measures how spread apart a set of data is. The easiest way for me to explain this is it's basically telling you, you know how you have the range of numbers? Like if you had from 1 to 10, the range would be like 9. Basically, standard deviation is kind of like the range, but it's just more mathematical, okay? And it's telling you like the average difference between each number instead of the whole set, okay? So, calculate the mean average of the set of data. When you are finding the mean, it's this X bar notation, okay? The mean or the average. And so right here, we're kind of going through here. When you're finding the standard deviation, the first thing you have to do is find the mean. Now, this right here, that means summation, or we could just call that sum for right now. And what it's saying is you're going to take the sum of all of the X values. So right here, this means add up all the X values, and then you divide by how many numbers you added. Okay, so this is amount of numbers. So one last time, the average or mean, okay, for your set of data is adding up all the X's in your data and dividing by how many numbers there are. Okay, once you do that, the next step is that you calculate the difference between each value and the mean. So you're taking the X is just your original value. And then you subtract it by an X bar we know is the mean. If you want to write it again here, you can. Mean. So you're just subtracting the original value from the mean, the original value from the mean. And we're going to go through and practice all this, okay? And then once you do that, whatever that answer is, the two that you subtracted, you're going to square them, okay? And once you do that, what does this mean again? Sum. Yep, you add them all up together. And you divide by how many numbers there were, right? And this right here, this is called your variance. And I know this seems like a lot right here, and as we practice it, it's really not going to be that bad, I promise. I just want to make sure you know what all these things mean. And then once you have your variance, you take the square root of your variance to give you your standard deviation. And this right here, that means standard deviation. And it also is saying all this on the left side. I just like it right there on the other side. And you guys know what the square root is, right? Okay, so we're going to practice. All of this right here, we're going to do right here. Okay. Also, I noticed yesterday as I was looking through this that I left off a row. So we're missing one row, which we'll end up kind of writing right here at the bottom. So my apologies. I know I should be perfect and I'm not. Okay, so the first thing we need to do is to find the mean. Okay, so I'm going to write this out in the first one. So mean, which we know really means X bar. And you find the mean by adding up all of the original data set and dividing by how many numbers there are. See, the sum of all of your X values divided by how many numbers there are. Okay, so just to write it out so we know exactly what we're doing, I'm going to go 5 plus 6 plus 30 plus 43 plus 9 plus 27. And the nice thing is that I get to use my calculator. So I'm going to type all of those values into my calculator. And when I do that, I get the value of, anybody find it? 120. Okay, now how many numbers did I have here? 6. So I am dividing that by 6. And 120 divided by 6 ends up giving me what? Good, 20. Okay, so 20 is my X bar value, meaning my mean. Okay? Any questions up to that point on how we found the mean? Okay, so the next thing we're going to do is we're going to write down all of our original X values. Okay, just our X values. So right here, these are our original values. So I'm going to write down 5, 6, 30, 43, 9, and you can see I'm missing that one row, so I'm just going to write 27 right below it. So I'm just writing down all those original values. Okay. All of those values have the same mean value, right? We found that mean. So next, I'm just going to write 20 for X bar on each of these. And again, X bar stands for our mean. Good. Okay, this part right here is where we are subtracting the X value and my mean. Okay, so you could rewrite it and put what it equals if you want to, but I'm not going to because I'm pretty sure I can just subtract, right? We can see this means we're subtracting the values. So 5 minus 20 is what? Negative 15. 6 minus 20 is? Negative 14. 30 minus 20 is? 10. 43 minus 23 is? 23. 9 minus 20 is? Negative 11, and 27 minus 20 is 7. And again, if you wanted to use your calculator on any of those, you can. Okay, this next part right here is that these subtracted values, we're going to square them. So negative 15 squared. Anytime we square a negative, it's going to end up becoming a positive. So if in your calculator you put 15 squared or negative 15 squared, you'll get the same answer, and that is 225. Very good. 14 squared is 196. 10 squared, 100. Good. 23 squared, good. 529. 11 squared or negative 11 squared, 121. And then over here, 7 squared is 49. I'm just going to kind of write it over here to this side. Okay, do you guys remember what it says when you have that summation symbol there? Oops. Add them all up. You're going to find the sum. Okay, so now what we're doing is we're adding up these numbers. So 225 plus 196 plus 100 plus 529 plus 121 plus 49. Don't forget that 49. And 1,220 is the correct answer. Okay? So for your variance, this number right here, it was what goes right here, 1,220. And we divide it by how many numbers we have. Well, the amount of numbers we have is the same that we had at the beginning, correct? So that means I'm going to take that and divide it by 6. And that equals what? Okay, so we're going to round that to the nearest tenth for right now. And so 203.3 is my variance. Now I want to show you something with calculators, because you can round and then take like the square root of that number. Or if you have that number in there, if you do the second button and then above x squared is your square root button. And so if I do second and then I press that, so it's asking me what the square root is. And then if I press second again, and do you see this negative sign right here? Do you see above it how it says answer? So I just press that, which says take the square root of my previous answer, like that, and then I press equal, and I get that answer. Okay? And we can practice some of those things too. Or you could just put square root of 203.3 and get it that way. Okay? So rounding to the nearest tenth, and again, we're going to write here that we took the square root of 203.3. Oh, sorry, square root of 203.3, and that answer again was what? 14.3. So that is the spread of my numbers. Okay, that's a standard deviation. Okay. All right. We ready to move on? Okay, so we're going to do the same thing now for a different set of data. And the first thing we always want to do is we need to find the mean. Okay? So let's go ahead and find the mean. And so that is our x bar. And we add up all those numbers together. So 24 plus 19 plus 15 plus 23 plus 18 plus 21. Add all those up. What'd you guys get? 120. And then how many pieces of data did I have? 6. And we divide by 6 and we get 20. So this is kind of interesting in that these numbers are not the same as the previous example, but right now we have the same mean. Okay? All right, so let's see about the standard deviation. So we find the standard deviation by taking our original set of data and subtracting the mean. Okay, so I'm going to write my original set of data. So under each of the x's, I'm just going to go back and write each of the pieces I had. So 24, 19, 15, 23, 18, and 21. What is the mean for each of those? 20, very good. The next thing that we do is we subtract that. Okay, so we subtract our x from our mean. So 24 minus 20 is 4, and 19 minus 20 is 15 minus 20, 23 minus 20, 18 minus 20, and 21 minus 20, 1. Once we have those, we square all of them. And one thing we know is that when we square a negative, it becomes a positive. So what happens is that all of these numbers become positives. Okay? So 4 squared is negative 1 squared is 1, negative 5 squared, 3 squared, 9, 2 squared, and then 1 squared is 1. After we do all that, what do we do again? Add all of those up again. So we have 16 plus 1 plus 25 plus 9 plus 4 plus 1, and that equals 56. And what do we do with that number in order to find the variance? Good, 56 divided by 6. And where did that 6 come from? Good, the total amount of numbers, pieces of data that we had. Okay, and 56 divided by 6 is 9.3. Okay, and then how do I find the standard deviation? Very good. We take the square root of 9.3, which is 3.1. So we notice from these two problems that here the standard deviation is 3, and here the standard deviation is 14. Okay? If you look at the numbers, do you notice how these numbers are closer together in terms of where the numbers are, would be on a number line? And so it's saying that the average distance between each of the numbers is about 3.1. Where on this set of data, do you see how like it starts at 5 and goes all the way to 43? So the average distance between these sets of numbers is 14.3. Okay, so standard deviation is really talking about the distance between each of the specific values in a set of data. Okay? All right, so we're going to move on. Do you have any questions before we move on right now? Okay, super complicated right now?
No.
Not too bad. Okay. All right, so I started by giving you guys these charts, but you're not always going to have charts. Okay? So we have to either know how to make our own charts or not use a chart. I like charts, so I end up kind of making my own charts, but it's up to you on what you want to do. But we do know that the first thing we always need to find when we are trying to find the standard deviation is to find what? The mean. The mean. Okay, and the mean represents x bar. So instead of writing out mean every single time, we like to use these abbreviations because it's much quicker, more simple. I don't know. Okay, so x bar. We're going to add up these numbers. 3 plus 5 plus 10 plus 12. And you add all those up and you get 30. And we are going to divide by what value? 4. And where did that 4 come from? The amount of numbers that we have. Okay, the amount in our data set. Okay, and 30 divided by 4, we're going to go to round this to the nearest tenth. To the nearest tenth. 7.5 equals our mean. Okay, so in order to find the standard deviation, who remembers what we do next?
Subtract.
Good, we're going to subtract. So I'm going to actually start by writing all of my x values like I did before. Okay, and so my x values were 3, 5, 10, and 12. Okay, and I know I need to subtract my mean, so next I'm going to go ahead and write my mean for all those values, because for me, visually seeing what I'm doing is easier for me. So I'm going to write 7.5 next to each of these numbers. Okay, and then I know that I end up subtracting them. So I'm going to put x minus my x bar. Again, I just like labeling what I'm doing, okay? And then I can go in my calculator, if I want to, and go 3 minus 7.5, which is, good, negative 4.5. 5 minus 7.5, good. 10 minus 7.5, good. And then 12 minus 7.5. Good. Okay, who remembers what we do next? Very good. So what we're doing is we're going our x minus x bar and we're squaring that value. Okay, and so in your calculator, 4.5 squared gives me what? 20.25. Very good, 20.25. And then our 2.5 squared is? And then I have 2.5 again, but this time it's positive, so I know it's still going to be 6.25. And this 4.5 is the same as negative 4.5, right? And so we get 20.25. So I don't even have to do all those. Okay, what's our next thing? Once you have all those values. Very good. And so if you want to in your notes, you can put like that you're going to add them all up. Okay, we know that when you're talking about adding, it's that summation symbol. Okay, so you add all those up. 20.25 plus 6.25 plus 6.25 plus 20.25, and what does that equal? 53. And what do I do with 53? Divide it by 4. And why 4? That's how many numbers I have in my data set. Okay, and 53 divided by 4 is 13.25. And so this number right here, that is your variance. So on the side, just because it's our notes, I'm going to write variance, which is, I believe this is theta, I think, I don't know. It's that symbol squared. So it's like a 0 or an O with a line at the top, okay? Equals 13.25, and then our standard deviation, good, we take the square root of that, we take the square root of our variance, and so I'm just going to write it right here to remind myself what I'm doing in my notes, but you don't actually have to write all of this when you're doing your homework. And when you do that, what does it equal? 3.6 is to the nearest tenth. On all of these, it's important to read the instructions, and if it says round to the nearest tenth or hundredth or thousandth, to do what it's actually saying. Okay? Now, there are no instructions like that right now in our notes, but in your homework there will be. Okay. Any questions on A? Okay, so on B it says, now increase each number by 2 and recalculate the mean and standard deviation. And they want to know, how does this affect the mean and the standard deviation? So we want to know, if we were to add 2 to each of our pieces of data, what is going to happen to both the mean and the standard deviation? So what I'm going to do is I'm going to put X, and I'm going to list my values, and I'm just going to add 2 to each of them. Okay? Because it said increase by 2, add 2. So 3 plus 2 makes 5. 5 plus 2 is 10 plus 2 is, and 12 plus 2 is 14. Okay, now we need to find our new mean. Okay? And so we find our mean by adding everything up. So here to the side, I'm going to put the mean. We add these up. So 5 plus 7 plus 12 plus 14 is 38. Divided by 4, which is what? Good. So 9.5 is my mean value. So next to each of my numbers here, I'm going to write my 9.5. Bless you. Okay, the next step is to do what? Subtract them. X minus X bar. 5 minus 9.5 is negative 4.5. 7 minus 9.5. Negative 2.5. 12 minus 9.5, 2.5, and 14 minus 9.5. Okay, and then our next step is to do what? Square those. Yeah, so we take each of those numbers and square them, and each of these numbers match those. So I don't even have to do any work here right now. So that's 20.25, 6.25, 6.25, and 20.25. And then we have to do what? Add them all up together. And we've actually already done that as well, haven't we? Which is 53 divided by 4, which is 13.25. And so my variance, which I'm just going to use the symbol for right now, my variance is 13.25, and then we know that our standard deviation, when we take the square root of that, will be 3.6. Okay, so thus, if you have a set of numbers and each number is increased by the same amount, the mean. So let's look at the mean. So here is the mean, 7.5 on my original set of data, and then here is my mean on the new set of data. What happened to the mean? It went up by 2. It increased by the amount that I increased each of the pieces of data set by, right? So we're going to write the mean increases by the same amount. And what happened with the standard deviation? So here my standard deviation ended up being 3.6, and here my standard deviation was 3.6. What happened? Very good. It stays the same. And if you think about this, remember how we talked about how the standard deviation is this, like the distance between each of the numbers in your set of data? And so if you're adding 2 to every single piece of data, it should still have the same distance. It's just that it's been like shifted on your number line. Okay, but it still has the same distance. Okay, so now we're going to do something different. Now we are going to, instead of increasing by 2, we're going to multiply each number by 2 and then recalculate the mean and standard deviation. Okay, so this time instead of adding by 2, we're going to multiply by 2. Exactly, from our original numbers in A. Very good. Okay, so again, I'm going to write my X values, and you can't see where they are because there's not enough room on my screen, but the original number was 3. So 3 times 2 is 6, and then we had 5, and 5 times 2 is 10, and then 10 times 2 is 20, and then the last number was 12, and 12 times 2 is 24. Okay, so now we need to calculate our mean. So for the mean, we are going to add up all of our values. 6 plus 10 plus 20 plus 24, and that equals? I count 60. Okay, good. And then 60 divided by 4 equals 15. I think somebody originally just told me what the mean was. So my mean is 15. Everybody good with that? Okay, so I'm going to write my mean down for each of my pieces in the set of data. And then the next thing we do is what? Subtract them. X minus X bar. And so 6 minus 15 is negative 9. 10 minus 15. 20 minus 15. And then 24 minus 15. 9. Good. And then what do I do? Very good. We square each of those pieces of data. And negative 9 squared is 81. Negative 5 squared. 5 squared. And 9 squared. And then what's next? Very good. We add those all up together. Very good. And we'll divide by, and why 4? Because that's how many pieces of data we have. And 212 divided by 4 equals what? Huh. Okay. So my variance is 53. And then how do I find my standard deviation? So we take the square root of my variance, which was 53, and what do I get? 7. I'm sorry. Okay, 7.28. Do you guys agree? Okay, so now we're going to compare again. It says, thus, if you have a set of numbers and each number is multiplied by the same amount, what happens to the mean? So again, we're going back to our original data. So in the original set of data, my mean was 7.5. My new set of data, we got 15. How do those compare? It changed, but how? Multiplied by 2. What's 7.5 times 2? 15. Okay? And so whatever you multiply each piece of data by, your mean is going to also multiply by that same amount. So therefore, the mean increases by the multiplied amount. Okay, now what happened to the standard deviation? So going back to the standard deviation, 3.6, this one is different. It is 7.28. So let's check. 3.6 times 2. What is 3.6 times 2? 7.2. And I believe if you had kept this standard deviation, if we didn't round it to the nearest tenth, if we would have put it to the nearest hundredth,
It's exactly the same.
it is exactly the same. So that's why you have to be careful on rounding. So if you wanted to go back and check this, was actually 3.64. And if you take that and multiply it by 2, it's 7.28. So what does that tell us? Good. Increases by the multiplied amount. So to restate what we kind of just went through here, if you added, so you have a data set, and let's say, like, for instance, in our classroom, let's say that class average was a 75 on the test, and I calculated the standard deviation and all this stuff, and then I'm like, oh my gosh, this just doesn't look right. I'm going to increase everyone's score by 5. Okay? Well, if I needed to find the standard deviation and all that stuff with that set of data, I wouldn't actually have to do anything, would I? I would know that originally my mean was 75. Would my mean would change by 5, right? We would just add 5 to it, so my new mean would be 80. And then whatever the standard deviation was, the standard deviation would stay the same. But if you are multiplying a set of data by the same number, the mean changes and you multiply the number, and your standard deviation changes by the multiplied number. Okay? These are things that you will end up needing to remember, and it will help you when you're doing your homework and your tests because you won't have to do a ton of work each time. Okay? All right, this last question you have to think about a little bit, and I'm going to let you guys think before I tell you the answer. But it says, what is the standard deviation of a class if everyone in the class scored an 85% on the exam? Now, who remembers what standard deviation represents? The distance between all the numbers. So if all the numbers are 85, what is the distance between them? 0. Okay? Because if you go, first of all, if we were to take the mean of the set of data, you know, if you added 85, 30 something times and then divided by how many, you'd get 85, right? So everyone scores 85, the mean is 85, and when you're trying to find the standard deviation, we subtract them, right? And 85 minus 85 is 0. Okay, so if everyone has an 85%, the standard deviation is 0. So we're going to write this out in words just so you have it. So the standard deviation is 0 because the difference between the mean and each score would be 0. And again, if you went through that whole process and you got the difference, and what's 0 squared? 0, and then you add a bunch of zeros and you divide by the set of data, you're still going to get 0. And the square root of 0 is also 0. Okay, good. All right, any questions? Okay.